Hello class, this is a video tutorial on determining if a line passes a coordinate. By substituting either values in the coordinate into the line's equation, we can test if a point falls on the line or not. So I'll demonstrate to you what we mean here. So take a look. So let's test whether y equals 3x plus 2 goes through this coordinate. So I'll demonstrate to you both methods that we're going to use. This first one, we're going to substitute just the x value. So take a look at what happens. We get y equals 3 times 2 plus 2. Notice how it's just this equation where x equals 2 is on this line here. Take a look. We would get the value, if you type this into a calculator, we get 8. So as you can see, when x equals 2 here, it should be 8. But this point, it should be 5. Well, it is 5. This doesn't match. So you can say, therefore, y equals 3x plus 2 does not pass. You can say the points 2, 5. Now the other way you can do it is you substitute both values of x and y and see if you get a true statement. Let me demonstrate here. So substituting 5 here, we get 5 equals, putting 2 into here again, we get 3 times 2 plus 2. But as we've seen, we get 5 equals 8. Well, you can say that 5 does not equal 8. Then we can conclude the same statement. You could then write just therefore, the line does not pass the point 2, 5. Now, had we done this graphically, it would look something like this. So graphing this perfectly, you would get a line 3x plus 2. And then if you were to graph the point 2, 5, it clearly isn't on the line. Okay, so I hope that gave you an insight to this. The remaining examples is pretty straightforward. It's the same thing. You can choose either. So either you substitute one or you substitute the other, or both, sorry. For this, I'm going to be doing the substitution of both x and y values. So here we go. So substituting both values, 3 goes into y. So we get 3 equals negative over 2. Notice how I'm writing out just that bottom bit. And substituting now negative 4 plus 1 from the equation. Typing this into my calculator. So negative of negative 4 over 2 plus 1. I get 3 equals 3. This statement is true. 3 does indeed equal 3. So you can say, therefore, y equals x on 2 plus 1 does pass the point negative 4, 3. And once again, just to demonstrate the idea, had you done this graphically, you can see there's the graph, negative x over 2 plus 1, and the point negative 4, 3, and it does indeed pass that point. All right, so let's now just finalize the final 3 examples. Here we go. So substituting both points, you get negative 13 equals negative 2 times 10 plus 7. Left hand side is still negative 13. Typing this into my calculator, I get negative 13. This is a true statement, so you can say, therefore, y equals this line passes the point, or does pass the point 10, negative 13. All right, so let's move on. Same idea, substituting -9 into y. 3/4 times -12 minus 1. Left hand side stays the same. 3/4 times -12 minus 1. I get -10. This is not true, so -9 does not equal 10. So you could say, therefore, this line does not pass -12, -9. Alright, final example. Once again, substituting both. 8 equals -20 on 4 plus 3. Take a look at what happens. Into my calculator, so the 8 is still on the left hand side. Negative of -20/4 plus 3. 8 does equal 8. So you could say, therefore, I'm going to be lazy here. Therefore, just change this and change this. We get -x on 4 plus 3 does pass the point -20, comma 8. Alright, so I hope that gave you an insight into testing whether a point does or doesn't pass through a line. Hope to see you in the next video. Hope to see you then. Best of luck.